All right, today we're going to be talking about chords and tangents. So a chord, all right, is a segment with endpoints on a circle. So right here, BE is a chord and CD is a chord. Reason being, their endpoints B, C, E, D are all on the center there. All right, so those are all chords. It says in a circle, if two minor arcs are congruent, if and only if their corresponding chords are congruent. So we'll notice here that these two chords are marked the same, which means that BE is going to be the same arc measure as CD. So if this one is 80 degrees, we know that this one is 80 degrees. Right? We know the perpendicular bisector of a chord is the radius. So we have a chord here, AB, and it is bisected by the radius WO. When that happens, it creates 90 degrees, and it creates two equal segments. That AX is the same as BX. So if this is 5, this would be 5. If this is 6, this would be 6, so on and so forth. And, all right, we have here two chords are congruent if and only if they're equidistant from the center. So XO, all right, would have to be the exact same as OS. All right, so let's do some problems here. So number one, we've got our chords DE and FG. All right, they are congruent, which means their arcs are going to be the same. So if this is 116, this one is 116. X is a central angle, which means it's going to be the exact same as its arc. So X is 116. For number 9, we have our two chords. BA is a chord and AC. They're both the same, which means their arcs are going to be the same. The arc over here at AC is X, which means the arc over here at AB is going to be X. If we add up all three of those arcs, the circle should add up to 360. 270 divided by 2 is X equals 135. These here, we've got our arcs, or our chords J, H, and HI. All right, they don't have marks on them, but it does say that their arcs are the same. So if their arcs are the same, it means I know those chords are going to be the same. So I can say 2x plus 1 equals 5x minus 5. I'm going to add that 5 over, then subtract that 2x, divide by 3, and I get x is 2. All right, for this one, it says the radius in this problem is 13. Okay, so QP is 13. And it says that RS is 24. And if RS, all right, we know that the radius is cutting that in half, so it means that this is 12 and this is 12. So let's see what we know here. It says RT. Well, we know RT is 12. TP. So we have to find this little part right here. So what I'm going to do is I'm going to draw another radius. I'm going to draw a radius from P to R. And I know this radius is going to be 13 because that's how long the radius is. And now I've developed this little right triangle where I can do Pythagorean theorem. So I can do x squared plus 12 squared equals 13 squared. All right. 12 squared is 144. 13 squared is 169. Subtract that 144 over. I get x squared equals 25. Take the square root. X equals 5. So that means that TP, all right here, is 5. Remember, the whole radius is 13. So if the whole thing is 13, and from here to here I've used up 5, that means I have 8 left over. All right, last one here. It says QG is x squared plus 5, and EQ is 3x plus 15. Well, how do those relate to each other? Well, those should be equal. So I've got x squared plus 5 equals 3x plus 15. Move the 3x and the 15 over to the other side in order to factor. Make our parentheses. What times what gives me x squared? X and x. Now I'm looking at what times what gives me 10, but somehow combines to 3. Well, 5 and 2, I can get to 3. And I want it to be a negative 3, so I want negative 5 plus 2. Set both of those factors equal to 0. So I get x equals 5 and x equals negative 2. So my answer has to be x equals 5. Up next, we have tangents. Now, tangents are different than chords. All right, tangents intersect the circle at exactly one point. That point is called the point of tangency. All right, a tangent line is perpendicular to the radius at the point of tangency. So, for example, I have a tangent line right here and right here. They touch it exactly once. Notice when that first tangent line crosses RP, that radius, it creates a 90-degree angle. It creates a right angle. And if tangents share the exact same exterior point, they are congruent. So this tangent is the same length as that tangent. So here's our first example. It says AB is a tangent, so AB's tangent, and it's tangent to BC, which is that radius, so this is a 90-degree angle. They want us to find X. Real quick, we know what this length, DC, is, because it's a radius, and all radii are going to be the same, so this is going to be 8, which means this whole side here is actually 17. So I can do Pythagorean theorem. X squared plus 8 squared equals 17 squared. 8 squared is 64. 17 squared is 289. Subtract that 64 over. I get 225. Take the square root of both sides, and I get 15 as X. Over here, a little bit different. We don't know what the radius is. All right, so we have it set up already for us, which is nice. So I would say X squared plus 32 squared equals. Now, what would this whole side be here? We've got X in that 16, so I would call that X plus 16. So X plus 16 squared. X squared would just be X squared. 32 squared is 1,024. Now, when we try to do X plus 16 squared, we have to write it out twice, because squaring means you just multiply it by itself. And what that means is over here, we're going to have to distribute. So X times X is X squared. X times 16 is 16X. 16 times X is 16X. 16 times 16 is 256. I'm going to combine some of my terms here. 16x plus 16x is 32x. I'm going to subtract this x squared over, and when I do that, right, those go away. So I've got 1,024 equals 32x plus 256. Subtract that 256 over, so 769 equals 32x. Divide both sides by 32, and I get x is 24.031. All right, this one, we've got two tangents, JM and JK. Since they share the same point J, we know that they are going to be equal. So I can say 2x squared plus 3x minus 2 equals 3. Subtract that 3 over in order to factor. Now we're ready to set up our factoring. What times what gives me 2x squared? 2x and x. What times what gives me 5? It's 5 and 1. So I've got 5x and I've got 2x. Is there any way I can make that into 3x? Well, yeah, if I have a positive 5 and a negative 1. So 2x plus 5 equals 0. X minus 1 equals 0. Subtract the 5, divide by 2. Add the 1 over. So x equals 1. Last thing here. This is what we call inscribed triangles. All right. So we're trying to figure out here what the perimeter of the triangles, and they give us the kind of bits and pieces. So these are all tangent lines. So AF is 12. And since they share a point with A here, that means AD is going to be the exact same length. So AD is going to be 12. BE is 6. And BE shares a point with BD, which means BD is also 6. FC is 8, which means since it shares a point with C, CE is 8. So to find the perimeter, you're going to add up all those sides. So 12 plus 6 plus 6 plus 8 plus 8 plus 12. And my perimeter is 52.